1.
Oh,
Whatever. Okay.
the lights zipper.
Okay. So this is part 2 of our conversation. Yesterday we did part 1.
Yeah.
So we're using square roots to solve quadratic equations. And I keep reminding you, what does solving a quadratic equation get you? What are you finding when you solve it?
Square roots.
A quadratic equation, what shape is it going to be?
Square. Parabola.
A parabola, right?
Yeah.
All right, here's a parabola. What, when you solve a quadratic equation, did you find? What? The what? Say it again. Well, remember, axis of symmetry would be
That.
the place where the vertex is.
Yeah.
You're finding the x, right? You're finding this point right here and this point right here. That's why it's plus or minus a lot of the times, right?
Yeah.
Sometimes you'll be finding, is this all on here? You might find one that just touches the x-axis in one place. So you just found only one answer. And that's why you get one answer. This is why you get 2 answers. And sometimes you get a no solution.
Yeah.
And that would be like this. It never crosses the x-axis, right?
Yeah.
So that's why you get a no solution. It's still a parabola. It's just that it doesn't cross the x-axis, okay? That's all we're solving for. So every time you take your square root of both sides and you get x equals plus or minus something, you found those 2 points. Does that make sense?
That is such a good visual for me. And like, if I think of this, because I always try to relate stories to this, right? Like the story of that equation is, if it crosses the x in 2 points, it has 2 solutions, right, Gary? If it barely touches it, 1. If it never touches the x-axis, no solution then, right?
Correct. Yeah, correct. So it's that's all we're doing. That's all we're doing. And so okay, here we go. So we're going to solve these just like we did yesterday's. The only difference is the solution is going to be a little more complicated, a little messier, because in the ones we did yesterday, as we noticed, all of them came out of the square root sign, right? Because they were perfect squares. Even if they were fractions, they were perfect squares, upstairs and downstairs. So when you took the square root, you got a nice, neat, non-square root number, right? And now these are not going to be like that. These are going to be messier. So what would I do first?
You add 11.
Add 11?
Yeah.
Add 11. Remember, my goal has got to be x squared. That's my goal. X squared equals. And then, so add 11. That gives me 3x squared is equal to 18. Now what do I do? Divide by 3. Divide by 3. That gives me x squared is equal to 6. Now what do I do?
Square root.
Square root both sides, right?
Yeah.
Square root both sides. Square root both sides. Now I get x is equal to
Plus or minus the square root of 6.
plus or minus the square root of 6.
Yeah.
Now, I want you to go one step further. I want you to now say x is approximately equal to, and I want you to get out your calculator and put 6.
2.45.
No, it's 2.5.
You do this. You do 6, and then you hit the square root sign.
I got 2.4.
Just 2 if you were.
Got 2.5.
And I want it rounded to the nearest hundred.
2.45.
You just end at 5?
What?
What's after 5? Anything?
That 4 would tell this 4 to stay
No.
put. So
What?
yeah.
Is there anything after
That would
5?
make it
2.4. Well, here it says 2.449.
Then you're going to
4897.
Yeah.
Okay, so Jake says it says 2.44. What?
94897.
948, whatever, right? So I want you to round these to the nearest hundred. So not the 10th, but the 100th. And so you have to look at the 1000th to know what to do with this one. If this was 5 or greater, which it is, this now has to go up to 5. So it's going to be x is approximately 2.45.
That's what I said.
Yeah, okay, I know, but I wanted to have the whole thing, not
Yeah,
just,
yeah.
just the
That
findings.
makes sense.
I just want to explain it, okay? All right, well, let's try another one.
It was also on the paper. That's the example they
All right,
gave you.
yeah, so let's say, here's number 2. What if I gave you 5x squared plus 6 equals 0? Okay, so write that down in your notes.
There. I did it.
All right, what would I do?
Subtract 6 from both sides.
Subtract 6 from both sides,
5x squared equals negative 6.
right? 5x squared equals negative 6. Now
Divide
what
by
would I
5.
do? Divide by 5, right? Divide by 5, divide by 5, and I've got x squared is equal to negative 6/5. All right, now what do I do?
Square root.
Square root.
All right, we can do that. Square root. Now what do I do?
Now you have to.
X is approximately.
What do you see here?
A negative, so it means no solution.
No solution, right? Immediately you know it's no solution because you can't take the square root of a negative number. Actually, ironically, in Algebra 2, there is a way to deal with that. But in Algebra 1 there isn't, so we can just say no solution.
We're
So
Algebra 1.
we would just say no solution. All right, let's try another problem. So 2, 3. All right, so what if I had 4x squared plus 10 equals, not plus 10, 4x squared minus 10 equals, I don't know, 6, okay, whatever. No, not 6, sorry. It doesn't matter, I don't want it to be equal, you know, so 5. Okay, sorry about that. That's the problem, okay?
4x
4x
squared
squared
equals
minus
15.
10 equals 5.
Yeah.
So what would I do?
4x squared equals 15.
What would I do?
Add 10 to both sides.
Add 10 to both sides.
Divide by 4.
Yeah, so important that I see your work. I want to see all of this, right? Don't ever do any of this in your head. 4x squared now equals 15, right?
Yeah.
Divide by 4.
Divide by 4. Divide by 4. Now I have x squared is equal to 15 fourths.
Yeah.
Okay?
And then square root.
Oh, they're both square root. We're both. Wait, no.
So now this is an interesting thing. Is the top a perfect square?
Yes.
No.
Is there any number times itself that equals 15?
No.
Yes, 3.
No.
3 times 3 is 9.
Oh, wait, no,
4
no.
times 4 is 16.
So,
No.
No? Alright, what about 4? Is that a
Yes,
perfect
yes,
square?
2.
Well, that's interesting. So let's try that. Let's just try taking the square root. If you have a perfect square in the denominator, you can go ahead and try that. So we suddenly have x squared is equal to, we have this, look,
No, it's not.
not x squared, sorry. X.
Oh, wait, it
I
is?
apologize. Thank you
Yeah.
so much. All right, but actually, before I get to this, I want to do one more thing to this. I want you to understand this. I don't know if you've learned this or not. So, equals, if you have a square root over an entire fraction, it's the same thing as putting the square root over each part of the fraction. You with me?
Yeah.
Okay? That is the same thing as that. It's legal to do that. Okay? So therefore, now, what is the square root of 15? Well, let's just do that. But we got to say plus or minus, right?
Yeah.
And then over, what's the square root of 4?
2.
2. And you could leave your answer like that. And that's an exact answer. It is x is equal to plus or minus that. Now, the trouble is, we don't know what that is. If I had to graph it on a thing, where is the plus positive square root of 15 over 2 or negative square root of 15 over 2? I haven't a clue, right? So that's where I have to get out my calculator. So now we get our calculator out, right?
Yeah.
And we actually figure out what is the square root of 15, right?
3.87298333.
This is what?
3.8729833.
3.87.
29833.
Okay, that's fine. All I need is the first three digits after the zero. So I'm going to say it's 3.87 is what I'm going to say. I'm going to just erase that 2. 3.87 divided by 2, and it's plus or minus, right?
Yeah.
Okay, so that's what my calculator says. So now I need to figure out what is 3.87 divided by 2.
Is that what you want us to do?
Yeah, go ahead.
Right?
So
Yeah,
x
1.91.
plus or minus 1.91.
I got 1.935.
Yeah, that's what.
Yeah, same.
Okay, so 1.9 what?
4.
935.
1.94.
No, oh yeah, 1.9. Yep, yep.
4. 1.94. I want it in up to the 100th place, okay? So now I know on a graph, I know that my here, if this is 1 and this is 2, and this is -1 and this is -2, I know I'm almost at 2, right? I know my parabola hits here and it hits here. And so I don't know, I don't know where it comes down, how far it comes down, because I haven't figured that part out. But I know where it hits the ground, basically, where it hits the x-axis. Does that make sense? Right? Is this clear? You understand how
Yeah.
we did this?
Okay.
Okay, yeah.
There's rush.
No, can you wait till after
Yeah.
lecture? 3, and I think that may be all I need to do. Hang on, let me just look at these really fast.
That seems like it.
I think, oh well, actually, let me just show you one other. What if they gave you something like this? I'm going to actually do number 24, okay, on the homework, just so you have it. Number 24, and it's -21 equals 15 minus 2z squared.
Whoa.
Did I do that right?
Yeah.
Okay. All right. So this is weird.
Yeah.
Why is this so different? What's wrong with this?
Turned around.
It's turned around.
Yeah.
That's okay. We can deal with it.
Okay.
So what do I do first?
You got minus 15.
Add 15 to both sides.
Yeah. No, minus 15.
Add 15.
She likes to flip
Now-
around.
Minus 15.
Now let me. Yeah. Okay. So we're gonna.
Add 15.
We want this to be all by itself, right?
I would be plus.
Because it's.
Because 15 is positive.
Yes, 15 is
But-
positive.
15 is positive.
So what are we saying that we should do?
Subtract 15.
Subtract 15 from both
I think we
sides.
should add 15.
We want the z's to be all by themselves, right? So we're going to get rid of this. That's a positive 15, so we got to do minus
What?
15.
Wow.
We just told you it's positive 15 because it doesn't have a negative.
Well, Jake,
front.
if I added 15, we'd
Got
have
it.
30 over here.
But is it? It's in.
It's not in why would
Because
it
it's
be
split.
negative?
Never
So
mind.
Right
Never
now,
mind.
right now we're solving it, and it's weird because we're now going to have the z squared on the right side. Now, you can change that. If you don't like that, this is what you could do. You could say, if this is equal to this, then this is equal to this, right? So I could just put an equal sign here and put -21 here. Do you agree with me?
Yeah.
It's totally legal. And then just ignore this, get rid of that. So I just changed it. So maybe I'll just do that. So now, but we still have to get rid of that 15, right? All right, so I'm going to subtract 15. Is this on? Am I on the thing still? Yeah. Okay. Subtract 15, and then that gives me -2z squared is equal to -36. Is that right?
Yeah.
-36. Okay, now what would I do?
Divide by -2. Yeah.
-2, not just 2. Right? That's a common mistake. A lot of people will just divide by 2, and then they still have that doggone -z squared. Divide by whatever's in front of the z squared, which is -2. Divide by -2, and then you have z squared is equal to positive 18. Okay, now what do I do?
Square root.
Square root both sides. Okay? So z is equal to plus or minus the square root of 18. Right? Now, you could simplify that, but you don't really need to. You don't really need to. There's a way to simplify that because there's a perfect square in 18. It's 9 times 2. I don't know if you guys have learned that or not. So we're going to go back and do that eventually. But for now, that's fine. Z is equal to square root of 18.
Yeah.
So use your calculator. What's the answer?
4.242.
Z is approximately 4 point what?
4.242.
Okay, so then 4.24,
Yeah.
right? Perfect.
Continues
And plus or minus, right? I got to do plus or minus. Good. Awesome. Fistify. You guys understand it? Pretty straightforward, right?
Yeah.
All right. So that's it for the lecture. I just want you to work on the problems right now.
Why
Get a-
do they have